Alright, today we're going to talk about direct variation. Direct variation is described by an equation of the form y equals kx. So when you're doing these problems, whenever you see direct variation, you can automatically assume y equals k times x. K does not equal 0. So y equals kx illustrates the constant rate of change, and k is the constant of variation, also called the constant of proportionality. So k is our constant of variation. Okay, so examples. Let's look at this graph right here. We know it's the equation y equals negative 2x. So what is the constant of variation? That is negative 2, right? That's k. It's the number in front of the x. That's negative 2. Now find the slope of the line. If I look, let's change color here, from here to here, that's down 2, so negative 2 over 1. So if I do rise over run, that equals negative 2 over 1, which is negative 2. Interesting. So let's look at our second one. Our constant of variation, we have this equation right here. Y equals 3/2 x. So what is our constant of variation? 3/2. Okay, and then find the slope of the line. Here are 2 points. So we have to go 1, 2, 3, up 3, over 2. So rise over run would be 3/2. What do you notice? That's the constant of variation equals the slope. Okay, so constant of variation equals the slope. Okay. So what point does the direct variation graph cross? Always the direct variation graph crosses the point 0, 0. Okay, so as you see, they both go through that point, and then the slope is what your constant of variation is. So let's look at some examples. The steps to graphing, we know we go through the point 0, 0. So you're going to start at 0, 0. We have to identify the slope. Okay, if you recall from the last slide, the slope is the number in front of the x. And then plot 0, 0 and count rise over run. So we're going to start at 0, 0. Our slope equals 3. So that 3 would be 3 over 1. That's our rise is 3. Our run is 1. So we're going to go up 3 over 1. And that's our graph. Okay. Next one, y equals negative 3/4 x. So start at 0, 0. Now our slope is negative 3 over 4. So remember, that's rise over run. Down 3, and run 4. So over 4. So that was down 3 over 4, and there's our line. Okay, so always on these, you want to start at 0, 0. Use your slope to count rise over run and make a new point and connect your points. Okay, so the next slide you are going to try some. There you try. Go ahead and try them. Start at 0, 0 and then count using your slope, rise over run. Okay, put those down and we'll go over them next class. The next thing, writing and solving direct variation equations. Okay, now 2 different ways to do this. I'm going to show you when you have to write the direct variation equation, you actually have to find your k value because you need to write the equation. K is part of it. So this is how we do that. We have y varies directly as x. So remember what I said. Whenever you see y varies directly as x, you know that is y equals k times x. Y equals 30 when x equals 5. So plug that in. We have 30 equals k times 5. Solve for k. Well, k times 5's opposite of multiplying is divide, so divide by 5, and k equals 6. So your direct variation equation, y equals 6x. Okay. Now the next part is use the direct variation equation, which is y equals 6x, to find x when y equals 18. So 18 gets plugged in for y, you need to solve for x, divide by 6, you get x equals 3. And that's it. Now, one thing, if you do not need to write your equation, what you can do is you know y equals k times x. You can solve for k, divide by x. So now when you have direct variation, y over x equals y over x. Alright, so when you have 30 over 5, so y is 30 over x, which is 5, equals, find x when y equals 18, that would be 18 over x. Cross multiply, 30x equals 5 times 18. Multiply that out, that's 90. And divide by 30. So x equals 3. So you get the same thing. So it all depends. If you have to write a direct variation equation, you've got to solve for k and do it this way. And then once you have your equation, it's very easy to plug it in and solve. If you don't have to write the equation, which you'll have some where you don't, you're just given basically this piece of information, then you can just do y over x equals y over x and solve the proportion. Okay? So next you are going to try that one. Okay, applications. One of the most common applications of direct variation is the formula d equals rt. That's distance equals, well, distance varies directly as time and rate. Alright, so distance varies directly, d equals r times t. So a family drove their car 225 miles in 5 hours. Write a direct variation equation to find the distance traveled for any number of hours. So remember your equation, d equals r times t. Alright, and that's what it always is. So when you have a distance, there we go, distance of 225 miles, you have 225 equals rate times time is 5 hours. So you need to solve for the rate. Well, this is r times time. That's multiplication. Opposite is divide. So divide by 5. And you get r equals 45. So that would be 45 miles per hour is your rate. So your equation, d equals 45t. And then you can put in any number of hours to find the distance traveled. Okay. Next one, the total cost C of bulk jelly beans is $4.49 times the number of pounds P. Write a direct variation equation that relates the variables. So the cost is $4.49 times the number of pounds P. So $4.49 times P. Graph the equation. So we start at 0, 0. You have $4.49 is 1 pound. 2 pounds would be $9.98. I'm sorry, $8.98. And so on. And you just graph that. Find the cost of 3/4 of a pound of jelly beans. So what you're going to do there is you have C equals $4.49 times 3/4. And you're going to multiply that out. Okay, when you multiply that out, you have, let's see, calculator, 449 times 3/4 is $3.30, when we round, $3.37. Okay, it's that one. Let's look at another one. Oh, that's where you try. Alright, that's it. Go ahead and try this one. I had one more, but apparently I was wrong. Go ahead and try that one, and we'll go over that tomorrow. Okay? This one talks about Charles' law, and the volume of gas varies directly as its temperature T. So B equals K times T. Go ahead, write that out, and try it.